Dear students, our solve for ISI JRF Statistics 2024 model paper. Question number 3. Define the matrix P in this for that ABCD transition probability matrix of a Markov chain with 4 states. Find the value, forward values, and the different values of ABCD for all disjoint, closed, and irreducible and recurrent classes. Very easy question again. So to solve this problem, we can take the matrix, and all the elements of P should be non-negative. That is a PEA. J is greater than equal to 0 for all I j, and the sum of the elements is summation of PEI j equal to 1 of each row. So for J, okay. So for the given matrix, the transitional probability matrix in a Markov chain with 4 states are the value of the given of the satisfy the following conditions. For the row 1, we can say 0 plus 0 plus 0 plus 1 equal to 1. So condition 2 is satisfied in row 1, okay. And row 2, condition 2. 0 plus 0 plus a plus b, so that is 1. Condition 2 is satisfied this. Then 0 plus 1 plus 0 plus 0, that is 1, okay. And c plus d plus 0 plus 0, this should be also 1, okay. So we can solve it from this. So a plus b equal to 1 and c plus d also equal to 1. Additionally, all statements should be non-negative, so a greater than equal to 0, b greater than equal to 0, a, b, c, d all will be positive. So therefore Phi is the transitional probability matrix of the given matrix chain for the 4 states, and the value of the ABCD must satisfy the following conditions: a plus b equal to 1 and c plus d equal to 1. First part done. Next is for the different values of the ABCD, we have to form this joint set over here, okay. So we have the following: state 1. So first is the absorbing state. So as if the self loop is happening, self loop in the transitional probability from the 1 to the state 1, okay. State 1 is 1, and there is no transition from other state to state 1, no transition, state 1, so that is 0, okay. So it's also an absorbing state in the self loop, so there is no transition to the other state 3, and states 2 and 4 are closed set also, okay. So based on the observations, we can identify the following disjoint structure. So 1 is closed, irreducible, reducible class, absorbing state. 2 is this 3, closed, irreducible, reducible class. 2, 4 is closed, irreducible, and reducible class. So therefore there are disjoint, closed, and this, and depending on the user's value, they satisfy the given condition of the